Alright, this is section 1-7 and it is called scatter plots. Alright, and on page 61 we've got example number 1 here. We're just creating scatter plots. So a scatter plot is a graph that shows the relationship between two sets of data. So here in example 1 we've got the relationship between the year and the score. So that's the comparison. For a different year you have a different score. And I didn't do this perfectly. I just put the dots on that look similar to what's in the book. And then there's a table over here on the right. That's where all those points came from. So when you're graphing your own, make sure that you graph it accordingly. When making a scatter plot, we have to make sure that we label this axis down here. The x-axis has to be labeled, so we labeled that with the year. And then up here, or on the side, we have the y-axis, and we labeled that with score. So make sure you're labeling your y and x-axis. And then, so all those points got graphed, and then the question here is just to make a scatter plot. So that's what it looks like. But just looking at some other things, what you want to notice is that the points seem to go up towards the right. Alright, so as the years, if you're looking at the years down here, you see that this is 95, 96, 97, 98, so on and so forth. And what is happening to the scores as you go further to the right? The scores are going up. So that's the correlation that you should be noticing between the two sets of data. That is the relationship between them. Alright, and on the page 62 here, there's a couple key concepts at the top. It talks about a positive, negative, and no relationship when you're looking at a scatter plot. So a positive relationship is like the top graph. That means as one number increases, as you go to the right, the y values are increasing. Alright, so that becomes a positive relationship. As one goes up, the other goes up. As one goes down, the other goes down. And you can see the dots are going up to the right. In a negative relationship, the dots, when they get graphed, will be going down towards the right. So as you go to the right, as that's going up, the dots are actually coming down. So they actually go in opposite directions. One goes up, the other comes down, and vice versa. And in no relationship, this last one you see here, the dots are just kind of scattered everywhere. There is no relationship. There's no pattern. You know, the further points on the left have high and low numbers, and so do the ones on the right. So they're just kind of scattered everywhere. So we would say that's no relationship. But then as we look at example 2, example 2 says, determine whether a scatter plot of the age of a car and value of a car might show a positive, negative, or no relationship. Explain your answer. Well, they show you a negative relationship graph, and you can probably think of this through, just cars. As cars get older, they cost less money. So as it gets older, more age, the money that it takes to buy it goes down. Alright, so that is a negative relationship because one's going up, the other goes down. And then on the other example there, it says determine whether a scatter plot of the birth month and birth weight data might show a positive, negative, or no relationship. And as you know, guys, anytime a baby is born, doesn't matter what month of the year, the weight of the baby is no different. Alright, so you can be born anytime during the year, the weight doesn't change. It's an important concept to know, so that would be a no relationship. There's no relationship between when you're born and how much you weigh. Alright, and the last example on page 63, there's a few parts here. I kind of just doodled through this so you get the basic idea. It says that a biologist recorded the lengths and weights of some largemouth bass. The table shows the results. And so they give you that group of numbers in the table. Now for you guys, when you do your homework, you're obviously going to plot those yourself. You're going to make a graph on your own. So part A says to make a scatter plot of the data. You're going to do that way more specifically than I'm showing here. Do it more like it's in the book. And then part B says, does the scatter plot allow you to draw a conclusion about a relationship between length and weight? And the answer is yes. You can tell that the dots are going up to the right, so that would mean that this is a positive relationship. We just learned that on the last part here. As one is going up, the other is going up. As one gets smaller in weight, it is also smaller in length. So there's a relationship there. And then this is the part that's new. It says to predict the weight of a bass that measures 22 inches. So I do have a 22 down here in this corner. And what we're going to do for this is you just kind of sketch something pretty small here. We're going to draw a line, just one line. By the way, this is not a line graph, so you're not connecting all these dots. If you start connecting the dots, you're doing it wrong. That's called a line graph. This is a scatter plot, so they're different. But I draw a line that basically fits the data, and it could be drawn a couple different ways probably. That was probably a bad line. Let's try a different line here. Alright, that's a little better. So what we're going to do here to make a prediction, we're predicting how much this weighs at 22 inches. So what we would do, you go over to 22 inches however you made your graph, you go up to that line, and then you come all the way straight over and you check what the weight is right there. So whatever you come to right there would be your prediction for 22 inches. Alright, there you go. That is section 1-7, last section of the chapter. Good luck.